So in this video, we're just going to discuss the solution to problem 7.75. So let's go right to the problem. Here, you need to think about what we're trying to do. And when we look at the starting material, which is this ammonium salt, and look at the product, what we actually are trying to do is make a bond between this nitrogen and this carbon here. That's why the little red line is shown here. All right, and you notice when this nitrogen and this carbon bond together, bromine is no longer present, and we have a 5-membered ring over here. So this is actually a cyclization. All right, so we want to make this 5-membered ring from this molecule here. All right, so let's look at the atoms involved. This is atom 1, 2, 3, 4, and 5, and then over here on this side, those same atoms 1, 2, 3, 4, and 5 are here. All right, so atom number 5 is the atom that contains the leaving group, and then atom number 1 is eventually going to be my nucleophile. So this is what we call an intramolecular cyclization. Intramolecular is a fancy word. It just means internal. So the nucleophile and the substrate are both within the same molecule. So the nitrogen here will eventually be my nucleophile, and then the carbon number 5, where the bromine is going to be my leaving group. Carbon number 5 is going to be the carbon and the substrate where the substitution takes place. All right, so let's see, in the first step, there's deprotonation by sodium carbonate. So let's look at what happens. This is the structure of sodium carbonate. This is the carbonate anion. It has 2 negative charges and then 2 sodium counterions. So when you see this formula here, this is the actual structure. So in the deprotonation, the carbonate comes in, pulls off the red proton. The electrons here go on to nitrogen. And so once that happens, I have an amine, a primary or secondary amine, here, and then I have sodium bicarbonate and then bromine that was here as a part of the salt. All right, so in the next step, now we need to think about the cyclization. So now we need to think about how nitrogen is going to attack this carbon. Right, and again, same 5 carbons, 1, 2, 3, 4, 5, or the same 5 atoms. So now we need to see how this is going to work. So in the next step, that's when you do the intramolecular SN2 type substitution. All right, so we expect nitrogen to attack here. So let's look at the arrows here. Nitrogen is attacking this carbon, and when that happens, bromine is leaving, and as a result, we get this ammonium ion intermediate. This is not the product, but we're very close. So the only thing that has to happen to go from here to the product is another deprotonation. So we bring in another molecule of sodium carbonate, and that deprotonates here. These electrons go on to nitrogen, and then we have our final product, which is this is the structure for nicotine. We have our final product here. We have 2 equivalents of sodium bicarbonate, which one came from the first step, and then the second equivalent will come from this step, and then 2 equivalents of sodium bromide, one from this step and one from this step. So here's some conclusions that we can draw. Number 1, the SN2 mechanism can happen intermolecularly, meaning between 2 different species, or intramolecularly, where it happens within the same species. Intramolecular substitution usually leads to ring formation. Whenever a ring is formed, we call that a cyclization. And then the SN1 mechanism can also be inter or intramolecular. As always, if you have any questions, you can tweet, you can email, or you can drop by my office. Peace.